I hope by now that you know that you're supposed to be using your notebooks. We had notebook quiz, so hopefully, can't make it go full screen. Hopefully by now I don't have to harp on that. Make sure you have your notebook. You can use the same one you have been using. Just make sure that you have your specific notebook. Graphing calculator, super important today. Please make sure you have that as well. So today we're going to talk about linear models. Sometimes you'll be given a set of data, all right? It looks like a sequence of some kind, okay? Maybe linear, it may not be. But you're given a set of data and you want to decide, can I create a model of that, all right? So data is messy, it's not easy, it's not always going to be a perfect line. But we can create models from things that are approximately linear. So we're going to start talking about what data looks like and how we identify it. So in example 1, we have a scatter plot, all right? So typically when you have a set of data, you're going to plot it on a scatter plot and you're going to look at it. And you're going to say, okay, what does this look like? So the very first one here, you'll notice that these data points are generally going in a positive direction. They're going up. So we would say that has a positive correlation. This is a vocabulary word, correlation. How is it related? That's what that means. This correlation is positive. If the data is going downward, it has a negative correlation, all right? If the data is all over the place, it has no correlation. These are the ones we don't like. We cannot create models out of these, okay? It doesn't work. So that's example 1. Practice 1, go ahead and pause, see if you can identify the types of correlations for both of these. Here's your solution. Okay, example 2. Now you'll notice I have this one written up here already. It's actually because this is the 3rd time I've tried to record this video. So I'm not going to rewrite them. But it gives you a set of data and it just kind of wants you to look at it, talk about it, get a feel for what's going on. So what I want you to do, the first thing I want you to do is find the finite differences. What that means is what's the difference between your y values, okay, your sequence here. What are the differences between each of those points? Is it linear? Is it an arithmetic sequence? Okay? Or is it close to that? So you'll notice here, I have these in fractions, but these numbers are not the same. Okay? We have 4.9, 4.7, 0.31, 1.51, 1.3. They're not even close. All right? So this is not linear data. If I were to plot all these points, it looks something like this. All right? I would say that has no correlation. That is all over the place. You know, if it were just, you know, the first half or just that half, we could say it's a negative correlation. All right? If it were just the second half, it's a correlation, but it's not linear. So I want you to be able to look at data and start talking about it. Plot, scatter plots, and look at it and see what does it look like. What can we start thinking about that? So here's your practice 2, okay? Plot it on a scatter plot, find the finite differences, and talk about it a little bit. Think about what all of those numbers mean. Is it linear? What does it look like? Those kind of things. Here's your solution. Now, before we go into example 3, which is where we're actually going to build a linear model, you need to make sure you have your graphing calculators. This is, I'm going to go through a graphing calculator example of building a linear model, then I'll do a full example with you, and then I'll have you do the practice. So the graphing calculators, I like the screenshots of them. It's really hard for me to find good ones. So maybe we can go there. There we go. All right. So with a linear regression, you have to be able to use your graphing calculator. So this right here is how you can find it. This is the easiest way to go about finding a linear regression. So the first thing that you do is you need to hit the stat button. I gotta think about the TI-83s and TI-84s are a little bit different, okay? And we're just going to use this little side note up here. I'm not going to go through the whole thing because this is a simple way to show this. So the very first thing you need to do is you will hit the stat button. You will hit enter. When you do that, it's going to bring up this screen. All right. Now notice the little numbers at the top. It says L1, L2, L3. That means list numbers. Okay. And you're going to put data points in there. So in the first part of the list, you're going to put in all the X values, and in the second list, you're going to put all the Y values. Now, occasionally, graphing calculators will get screwed up. You'll accidentally delete a list without realizing it, and these numbers may say L2 to start with. Okay, it may say L1 and then skip to L3. That's okay. All right. You just need to adjust later on. So if your graphing calculator is messed up, go ahead and just adjust, and then I can help you fix it when you come to class. It really, if you know how to reset a graphing calculator, you can just reset it. So once we do that, once you have all of your data points in, you're going to push stat again. Okay, something's on my smart board. You're going to hit stat again. And once you hit stat again, instead of hitting enter, you're going to arrow over to the calc, to where it says calc. And then you're going to go down to number 4 that says linear regression. This is the one that we're focused on in this lesson. Now, if you have a TI-83, this is the screen that's going to pop up. It's going to say linreg. And then what you have to do is you have to type in L1 to say we want to use list 1 for our x value, comma, L2 for our y value. And I have to remember, I don't have my graphing calculator right in front of me right now. L1 and L2 is a shift key. I think it's above like numbers 1 and 2. Make sure the comma is in there or it will mess up. The comma is right next to, is right above the 7, I think. So then what will happen is you'll get this. It's going to give you a line, okay, an mx plus b type formula, except it uses ax plus b, and you just need to plug in the points. So this would be y equals negative 2x plus negative 1. That is a linear model, and that's how we're going to do all of these problems. Okay, I'm going to go back to our notes now that we have done that. And we're going to now do this example, all right? So I'm going to use the graphing calculator to do this whole thing. So if you would, I'm just going to go ahead, I've already done it on my graphing calculator, so I will show you. When I do the graphing calculator, I put these numbers into my x value, I put those into my L1, I put these values into my L2, and then I ran my linear regression, and I got y equals negative 4.64 x plus 9603.96. All right, so that is my model, and it said now this one used 0 to correspond to the year 1950. I use 1950 as my first point, so you can do it either way. So it's in the unlikely event that a linear model in part A remains valid far into the future, will there be a time when death from heart disease has been completely eliminated? So what you do then is we say, okay, we want y to be 0. We don't want there to be any heart disease. And then you solve this. You solve the equation just like we would in Algebra 1 when we were solving equations. I subtract 9603 from both sides, divide by negative 464 with a negative. And I would get the year 2069.80, all right? Or we could round that up and say the year 2070, there will be no more deaths by heart disease if the model stays the way it is. Now, typically models are not exact, and at one point this model will probably bottom out and say, okay, now this is what we have. The idea of heart disease being completely eliminated is a little unrealistic. But these are models, these are to help us make predictions. That's why we do them. Okay. Here's a problem for you to try on your own. It asks you to draw the scatter plot. You can do it on your graphing calculator and then just do a rough picture on the do a rough picture on your notes. Okay. Here's your solution. Okay, that explains everything. And that is it for today. We will see you tomorrow.